Hello and welcome to the TAMGeF user guide. This portion of the video will be dealing with a tutorial of how to use the API. I will assume that the actor is a developer. This class is the input mapper, the one responsible for mapping all the input from the input device. This is what you use to map the input. You will see how to use it later. Now, the next thing that we have is the color struct that is used to pass a color to 3D shapes. We have now the circle class, which is used to draw a circle. You will see how to use it right now. So you can see there the input mapper. It's mapping the input. See input mapper name. You can see that the input mapper receives a function and some variable. You can see it there too, receiving some raw coordinates, mapping them according to the mapper function. Those are the raw coordinates. Now you see the new circle constructor. Receives the screen width, the screen height, the radius, the colors, and the transparency. It also has a boolean value that determines whether it is filled or not. And finally we draw the circle passing the input mapper to it, which has the coordinates that we want to draw it to. Now you will see it in action. You can see that it's actually two circles that we are drawing. You will see why right now. So see in finger, right there, we have two circles and one has a lower radius. That's why. So you can use the API like that too. Now we have a triangle class, which draws triangles. Now we will see how to use it. It's very similar as to how we use it with a circle. It's very similar to it. It just doesn't have some of the arguments, like the screen width, screen height, or the radius. But it keeps the color and the transparency. It also doesn't have the boolean value for field or not field. There is no outline of a triangle, but you can do that with a line. So you can see it now, right now that I erased the arguments. And we have the triangle. We will now display the triangle. So you can see it's drawing a triangle in a very easy way to do it. The reason they have different colors is because we are passing them different colors with the general color function. Now we restore it to how it was. And we have now this square class that draws a square or rectangle, whatever you want, square or rectangle. So the way we're using it, once again, is very similar to the circle. It's actually closer to the triangle one. But they are all very similar. How to use them. So now you will see. There we have a rectangle, green rectangle. It's being drawn using the API. We have the right triangle. That one draws a right triangle. It has a clear function, a compound function, a draw function. The compound is to combine them. You can see we are just an input mapper then. And we're drawing a triangle. That's where we compound. The last two booleans are for flipping, vertical flip or horizontal flip. And that clear actually resets the pointer to the original triangle. So it will be the new triangle dot draw. It resets it to that one. So basically what it means is that you compound them in certain positions, like you saw that place. But if you do clear, you are no longer compounding the last triangle, but on the original triangle. That's the line class. It also can be compounded. So we'll see how to use the line class now. There it is. We have the input mapper. We create the line class. This one has a thickness argument, which is the thing that you can see there. That determines the thickness of the line. The set endpoint function is what determines the end of the line, while the draw determines the origin of the line. So it's important to call set endpoint before draw. Now you will see the lines. They are connected by the centers of the circles. And now we have the cube, which is a 3D shape. It also has compound, it also has the clear function. You will see it in action now. There is the cube. We create a cube class. We pass it the size. We are not passing any structure with color, so we will use a different color. Then we call the draw and pass an input mapper. That's a compound. We're compounding 4 on top, 4 on left, and then we clear, so the pointer is reset to the original one. We're in there. So we are compounding 4 to the left of the original, and then we set. That means that now the pointer is on the last of the compound cubes. When we set, we can set in any position, compound in any position. We can also clear one specific position. So if we set some position, we can clear that pointer too, and we no longer are set. So let's see this in action. This is what the compounding of those cubes has as a result. And we have the pyramid class. So now we will see how to use the pyramid. That's the pyramid in a cube being compounded. But now we will see how to use only pyramids. So you can see it also receives size, and you draw it with draw by an input mapper. That's how you compound it. That's for the degrees of rotation. That one is being rotated. The boolean is what determines whether there is rotation or not. And those numbers are for rotation. That's a struct. It has a color. It is being passed on the cube, so you will later see a cube with color. So let's see it. So that's a cube with color and the pyramid on top, compounded on top. And now we have only the pyramid. So you can see that one is rotated and one is compounded on top. we have the helper. That's an interesting function for the helper. That's a mapper. Map pixels to GL coordinates in 2 dimensions. And that one generates some colors and outputs them to RGB. Now we have the visualization handler, which is the one that handles the OpenGL context creation. You basically pass the initGL, the ResizeGL, the PaintGL to the initGL, ResizeGL, PaintGL of your GUI. You will see how to do it now. There you see it, initialize.gl, and there's the initGL. Those coordinates 1.0, 1.0, 1.0 are for the RGB, the color. Right now it's being white, but we can change it to whatever we want. So we'll change it to red. And you see that the context is red now. And then we have the resize.gl. It only receives the width and the height of the window that you want to resize. And it goes to resize.gl too. Then the PaintGL, that's one of the most important ones. That's what handles the actual drawing. You will pass a function to that one, function that handles the drawing. And you have a list on the other side. That list must have the shapes. You can have one shape, 1,000 shapes, but it must have the shapes. So that's how you use it. And now we will see the lip motion application. It is using the API and it's a very simple application. This one is aimed to a developer too. But this is a very simple application. It simply handles the tracking of a hand and fingers. So we'll show it now. So you can see right now the hand. It's being drawn using the API. You can see the line, you can see the square, you can see the circles as I showed before. You can see how I'm moving one finger, another finger, another finger. I'm moving my hand, tracking it, moving fingers, moving hand and fingers, hand, moving my hand. Now I'm moving my hand a lot and fingers. So that's the user guide for the lip motion application.
This video is to show you how I use the Kinect sensor. The sensor from the Kinect I use is the lighting independent infrared sensor. This sensor transmits at a speed of 30 frames per second. Each frame has the information you need to draw the skeleton. For example, each frame has the body tracked by the sensor at that time that the frame was transmitted. For example, as you can see here, there is no body in front of the sensor. Now I will place myself in front of the sensor for my body to be tracked. While my body is tracked, I get every joint of the green dots represent the joints. And I draw a line from the head joint to the neck, from the neck to the spine base, to the shoulder base, and from there I start drawing the left shoulder, right shoulder. And so on and so forth. Then from there, once I have the position of the joint, you have to translate it from centimeters to pixels, and from pixels to the OpenGL coordinates. It's very interesting the things you can do with the sensor.